Hello, thank you for joining us today for the first webinar in our data science series, Defining the Multi-Paradigm Data Science Workflow. We are so pleased to welcome today's presenters, Swede White from our Public Relations team and Abrita Chakravarti of Wolfram U. Swede will begin today's webinar by sharing 5 things you need to know about multi-paradigm data science, communicating Wolfram's vision for harnessing computation to take data science to new levels of analysis and understanding. Next, Abrita will dive into specifics by working through the data pipeline with the use of a practical real-world example. By the time we close today's session, we plan to share many online resources and links with you and make a convincing case how Wolfram Technologies can help you take a multi-paradigm approach to data science. My name is Jamie Peterson, Technical Programs Manager with Wolfram Research, and I'll be your online host for this data science webinar series. I'm joined by several of my Wolfram colleagues behind the scenes to respond to your typed questions during the webinar and help point you to the resources you need. Feel free to submit your questions using the control panel on the right side of your screen. You can resize the windows to customize your webinar experience. We've had good success with Firefox and Chrome browsers, so if you experience any problems with the screen or audio streaming, you might want to try logging in with a different browser. Today's webinar is a great opportunity for you to learn more about the various stages of a data science workflow, from importing data to machine learning, exploring analysis to final visualizations. The presentation notebooks will be available for you to download at the end of the webinar, and they can be useful resources for you to build your skills with the Wolfram language. Well, before I pass the microphone to Swede, I'm going to share a quick poll question asking about your motivation for participating in today's webinar. When the poll question appears on your screen, please select your response and we'll share the answers after everyone has a chance to respond. Thanks again for joining us. Our first presentation is coming up next.
Okay, it looks like we have about 31% of people that use the Wolfram language and are interested in data science, and about the same people that use data science and are interested in Wolfram language, and 39% at I am just interested in learning new things, and we hope that you will learn new things in our webinar today. My name is Swede White, and I work in public relations here at Wolfram Research. And before we get started with Abrita, I'm going to go through 5 things you need to know about multi-paradigm data science and what it means. So let's go ahead and get started. So I'm going to go over 5 key points here. Basically, harnessing the full power of computation, leading your processes with questions rather than techniques, utilizing fully customizable reporting, and taking advantage of natural language understanding, along with using multiple types of data and computational tools. And so on each slide of these, I'm going to have resources here at the bottom, and this notebook will be available to you after the webinar ends, so you can check out these various resources. So first, harnessing the full power of computation. What do we mean by that? Well, you may think of data science often rooted in statistical analysis, hypothesis testing, regressions, t-tests, z-tests, things of that nature. But as data have become more complex as we move into 2018 with new types of data and new techniques being developed constantly, the type of computation that you need to analyze that data must be cutting edge and must be able to handle different types of data with different methods like machine learning, signal processing, computer vision, and neural networks. So by harnessing the full power of computation, your tool should be able to select algorithms automatically for things like classification and prediction. Also bringing the advantage of pre-trained neural nets to your data, and also automating as much as possible, including filling in missing data with imputation. So down here in the resources section, there's a talk here from Etienne Bernard in our advanced resource group that he gave in Prague about using symbolic neural networks and automated machine learning, and there's a downloadable notebook with that link to get started with that. So a process led by questions rather than techniques. What do we mean by that? Well, using automated machine learning, natural language queries, and triggered reporting is going to free up your process to ask better questions of your data rather than being hung up on methods. You'll be able to take tools and use what works best and be able to ask better questions to get to better solutions. Also, utilizing super functions in the Wolfram language saves development time, and you don't necessarily have to be an expert in machine learning or statistics to utilize these tools. For example, automatically determining optimal algorithms for a particular task is something you can do in the Wolfram language with just one function. You can also take advantage of knowledge-based programming with curated expert knowledge. So in our Wolfram knowledge base, we have lots of domain expertise built in that's curated by experts in life sciences, engineering, extensive geocomputation, words and languages. And then our algorithm base is quite extensive as well. We have over 5,000 functions built into the Wolfram language that are easy to use. Fully customizable reporting is very important in communicating your results from your data science project. By using the Wolfram language, you can utilize deployment to public or private clouds using dynamic content. You can also build instant APIs to update reports for a wide variety of interfaces with real-time data streams, and deliver your results from models and analysis directly to end users. So some use cases include direct-to-client data analytics through a variety of platforms, including mobile and web, also rapidly deploying microservices, and centralized computing and reporting with cloud products. Natural language understanding is something that sometimes seems difficult to implement, but with Wolfram language, you can take linguistic programming and use free-form input to get to an answer you want. You can also build custom grammars for customized natural language processing applications. So what that means is you can take your own data and have it work something like Wolfram Alpha. So with your own data, you can have a free-form input and get customized reports returned. What this means is you're democratizing access to data and access to these tools so that anyone from the C-suite to the sales team or the data scientist can ask free-form questions and get results. Multiple types of data and computation are becoming more and more important in data science. Real-world data is indeed messy and requires a system that can process, model, and visualize it in an automated way, especially as more and more data is being generated and data streams are becoming faster and faster and with increasing amounts of data. What the Wolfram language offers is a unified framework for data wrangling, pre-processing, visualization, modeling, and reporting, so you're not switching between languages, applications, or different packages. You're not having to access or call many different types of libraries to get the job done. You can also access built-in APIs in the Wolfram language and also external services and databases, and utilize a system with support for hundreds of types of data. So in conclusion, the 5 things that you should take away from multi-paradigm data science is harnessing the full power of computation, leading your process with questions rather than techniques, utilizing fully customizable reporting, and taking advantage of natural language understanding, and using multiple types of data and computational tools all in one framework. You can easily achieve all this and more in a unified data science workflow, and we're going to learn how to do that in detail right up next.
Thanks, Swede. I've put up a new poll question that we are asking about your use of machine learning. And then we'll have Abrita Chakravarti giving us her pipeline presentation following that.
All right, so we see that some of you, 16%, do use pre-built models to train your data. 24% work on building your own custom models. About 48% use traditional methods, regression models, and other classifiers, and so on. About 16% are into deep learning, and 42%, a little less than half, do not use machine learning. Great. We hope we have a little bit for everyone, but especially for the beginners. We hope we can give you a sort of an idea how the Wolfram technology can be used in this new multi-paradigm approach to data science. What I hope to bring to you today are 2 quick examples through which I can show how you can build up a workflow to do your the kind of data science you want to. So let's get started. Now, in the outline for my talk today, let me quickly share that first. I just want to quickly show our view of the multi-paradigm data science. We did a great job of highlighting our 5 important points, the way we see it. And then I'm quickly going to dive into an example of a workflow. I also want to touch base on how you can actually quickly go from playing around with code in a scratchpad to shareable analysis with the help of our technology. And finally, I want to bring up the case for a data science pipeline, why you should even think about it or how it can be helpful in your project. So currently, we see all these nice infographics about data science, all the stuff that you need. You need mathematics and statistics or machine learning or things like that. Sometimes I find it a little intimidating, and that's just personal experience that, oh my goodness, I mean, all this stuff, I don't know much of it. How do I get into data science? I like this more fun infographic I found, which, I didn't even know something like data artistry existed, but, that's a nice way of putting things. I can be a data artist while I'm doing data science, or, data surfing, data wrangling, data mining, and all these different ways of approaching data science. And so we are bringing to you our approach in multi-paradigm data science, and, we welcome you to check out our website on this. But let's leave all that aside. Let's just dive into some data science and work with some data and see how we can build this up. So let's push out a quick poll. I want to do a tweet analysis. That's very common nowadays. You have a tweet stream and you want to do some basic analysis for your social media. So we're going to push out a quick poll, and I'm going to see what sort of a keyword you might be interested in to do this tweet analysis. So we can look for tweets about the World Cup or the Avengers Infinity War or, the S&P 500 index, or we can look for Wolfram tweets about the Wolfram language. Let's see who wins. All right. So pushing out the results, it seems like World Cup was a clear winner. It got about 35% of the votes. And so it's interesting because I prepared my presentation with the World Cup keyword, and I'm very happy like the majority of you agreed with me. So let's get started. I'm going to open up here. I'm going to start sharing my screen again. Okay, and I'm going to open up a new notebook and just write out some code, and then we can work through this together. Okay. So one word of caution is that, for some of you, this might be a new programming language. So don't get lost in the details of the code. Try to follow along. And of course, I'll make all this available. So, you can always play around with it at the end. So just try to follow along what the intention, the idea behind what we are trying to do. So I'm going to get started by connecting to Twitter. And I have already tried this before. For those of you who would be doing it for the first time, the program quickly takes you to your browser to allow you to authenticate the Wolfram language to connect to your Twitter account. And once you're done with that, you can actually start interacting with Twitter and get your data from there. So let's start as we thought we'll work with the keyword World Cup. And so I've set the keyword here, and then now I'm going to get the tweets. And just for the purpose of this example, I'm going to restrict my language to English because I want to do some sort of sentiment analysis. And right now our classifier works with only English language text for sentiment analysis. This is our inbuilt classifier. I mean, if you are welcome to train your own classifier on other languages, that works fine. But just for this example, we are going to use a pre-built model. And so I'm going to restrict to English. And so let's see if I can get the tweets here. And these are the tweets that I have. So first thing, what can we do? Let's do a timeline of the tweets. So let's go down here, and I'm going to do a tweet timeline. Basically, I'm doing a histogram of the times at which the tweets went out. So I think I got 500 tweets. And so you see between 10 and 11, there was a rise and then a drop. And so you can see how this might be useful if you're trying to follow your social media, the social media analytics for your company, or just for the fun of it, you're trying to follow tweets on something, you want to see how people are tweeting about a particular topic. Is there some insight you can derive from the pattern according to time? Another very basic analysis, we can look at favorites like likes and then maybe retweets. So let's do a quick histogram of favorites. So most of the tweets, there were not like too many times, but there are these outliers here. One that was retweeted about 200 times from this 500 tweets that we got, we downloaded. Let's also look at I'm sorry, this was just the favorite count. One of the tweets was liked more than 200 times. Now here are the retweets. Okay, so again, we see that, most of the tweets are retweeted a couple of times, but, a couple of hundred times, but then there are some tweets that have been retweeted a lot more number of times. Now, finally, let's go get to the interesting part, and I'm just going to work with 50 of the random samples from the data that I got. So I'm going to just take 50 of these tweets, and then I'm going to try and do some sentiment analysis. We have the classify function in the Wolfram language, and there is a pre-built classifier. It is named sentiment, and you can use it like this. And it should tell me whether the language of the text of the tweet, whether it was neutral, positive, or negative. And once I have that, I can also, visually present it, or just let's summarize it quickly. Just let's take a look at the numbers. So of the 50 that I got here, 30 were neutral and 20 were positive. I didn't, so there were no negative tweets apparently, just for this case. So once I have that information, I can also visualize it quickly. So I get a pie chart. This is not that interesting. The last time I did it, I did get some negative tweets. So it was a little more interesting to see, the comparison of the positive and the negative tweets. Okay, so now that I've shown you this, and we did this with the World Cup, right? I want to show you how easy it is to just, switch over to whatever it is that you would like to do, whatever other keyword that you would like to pick and do a similar analysis on. So the reproducibility of your analysis. So, S&P 500 was the second most polled or voted for keyword. So I can switch to that, and let's see if I can get about 1,000 tweets for that. I'm using the, I'm sorry, the ticker symbol for S&P 500. And here what I've done is I've actually, the analysis that we are doing just before, I've just, redone it. I know there's a bunch of code, but all I want to show you is that is the same analysis. I've just prettied it up. So most of the code here is, to make it look nicer, square, and so make the picture square of the right size, and then use a certain kind of plot theme and that stuff. And the reason is because I want to create an infographic out of it. So I'm going to run this, and then I'm going to create the infographic here to show you, how easy it is to quickly create something like this to share your report. And the next thing I want to show you is this I created on the fly, right? But what if you have to create this over and over again? So in that case, you can set up automated reports. So let me show you the template of a report that I have created. So this is a special notebook. This is a template notebook. And what you can do in template notebooks is that you can have placeholders. So for example, here I have the keyword placeholders. And so I can run this template notebook by supplying it a keyword over and over again, and it will generate the same sort of report. And I can change the keyword to whatever it is. And so the code to do that is here. Okay, so you see I'm just getting the template notebook. The first part of the code here is that I'm getting the template notebook, and the second part of the code is where I'm setting the keyword. Okay, so this time I'm going to do it for Wolfram language, and I go ahead and do that, and let's see what kind of an analysis we get back for the Wolfram language. Now this report, this is the quick um, uh, the quick report I generated. I apologize for the little typo here. I forgot to use the placeholder there instead of actually hard coding the keyword. But anyway, you get the idea. And what I wanted to point out is that here I used generate document to do this once. I can deploy a scheduled task to the cloud, and I can have make sure that this report is automatically generated, for example, every day at 5 o'clock, and then, I can have it set so that it is sent to specific people who need to look at that report. So the intention of showing this example was that we did some data science here. We didn't stop to worry about what sort of modeling we were going to use, whether we were going to use machine learning or statistics or some, we didn't get into the heavy details. We got some data, we played around with it, we did some basic analysis, we prepared our results to share with other people. And this is really the multi-paradigm approach to data science that we are suggesting, that you can do a whole lot of different things and you can automate it. If you don't like using the pre-built sentiment classifier we have, you can train your own, and we have the framework and the code available for that. So so this was very quick and exploratory. Let's do a little more a little more linearized approach to how to analyze some more data. So moving on, I'm going to save
Preeta,
this.
could you make that notebook up at 150 maybe? That might help see some of those details.
The one that's there right now.
Right.
Okay, I have it at 150. I'm moving to 200. Is this better?
Yeah, that looks better. Thanks.
Okay, and what I am also going to do is I'm going to share this notebook with you in a little bit. Actually, I think I can share it with you right now if you want to look at it. I was going to keep this up my sleeve for later to show you how easy it is to do this in the Wolfram language, but I'll go ahead and share it with you right now. So let me see. I'm going to copy the hyperlink, and I am going to post it on the chat window. Okay, and so you should be able to download the notebook from there, or open it up in cloud and play around with it if you want. But let's move on to my next example. We are going to work with some real estate data. So I was able to find this publicly available real estate data on the rolling sales of homes in New York. And the data is available for like 5 different boroughs. So let's just take a quick poll and decide which borough the current audience likes today, and then we can go ahead and work on that. So Jamie or Cassidy, if you could push out the poll. I have data for Manhattan, Bronx, Brooklyn, Queens, and Staten Island. And I will try to show you to work through the workflow with you today on one of those data sets. Okay, we're closing the polls. So we have a winner, Manhattan. So let me try to grab some data on Manhattan, and then we can get going. So here's my screen. So I'm going to get the data from this URL here, And let's see, what our import function allows you to do is actually check out what is available from this URL. So I can see that, okay, that's there. I can see from the URL it's an XLS file. So I can also see what can I get from this. So I can get the data. I can get it as a data set, which is our data structures in the Wolfram language to nicely organize your information. I can get it as formatted data, formulas, images, and sheets. I'm just going to go with basic data. And I know in most Excel sheets, you usually have the data on the first sheet. So I'm going to go ahead and actually just grab the first sheet from this XLS. And so this is the raw data here. And, you know, every time we get some raw data, we like to take a peek into it. So let's see the first 10 lines of the raw data. So we have some information here about the file here, you know, neighborhood names and descriptive data and so on. And here we see we actually have what looks like the feature names, right? And then I think the real data starts from here. Right? But that's not always enough. It's always good to see what's at the end of your data too. And that's what we are going to do here. And as a lot of you might have suspected, this is an XLS, right? So the Excel sheets have lots of blank rows, and I can see them right here, a good number of blank rows. So now that we've gotten our data, so this is what a lot of you often do, and this is what the phase where we call it something like data import or data acquisition, something like that. So we got the data here, and now we see there might be some problems with the data. So what we do in this phase is something that's often called data cleaning. So let's go ahead and do some data cleaning. Let's start out by looking at the length of the raw data here. My colleagues are answering your questions right now, but if there are some questions we can't get to, we will have some time at the end of the presentation. I'd be happy to take questions then as well. So please be patient if we cannot get to your question right now. We'll definitely try to get to it at the end of the presentation. Okay, so an easy thing to do, I saw all those empty rows, right? So an easy thing to do is to just get rid of those. So I have the raw data and I'm going to get my clean data out of there, at least clean at this step by just deleting all those empty rows. And now I can look at how many real rows of data do I have. About 17,727. And I also want to get all the features. Remember, it was there up there in the 5th row. So let's get that here. Okay. So we have information about the borough itself, but now we got the data. We pulled in the data only for Manhattan. So I'm guessing this will be the same for most of the rows, if not all. It should be the same for all the rows. We have information about neighborhood, something called building class category, tax class at present, block, lot, easement, and a whole bunch of other things. I can see the address, which might be of interest, the zip code, residential units, commercial units, and total units, some square footage, year built, which might be interesting. And then, of course, there's sale price and sale date. Those should definitely be useful. One thing I want to point out here, like a lot of data scientists or people trying to do something with data science, is that we do not always have all the expert information at hand, right? What does this really mean? And while I had I was lucky enough to be able to talk with a realtor friend of mine to get an understanding of what all this is really about. I want to point out that that's not always necessary. It's good, of course, it's very good to have expert input, but sometimes you can just play around with things, and especially during cleaning or exploring data, let's not get too hung about what exactly some of the features mean. So let's see. I'm going to store the number of features here in a variable because I'm going to use that later on. So we have 21 different features. Now let's see how we can use them. To just visualize this and use it later on, I'm just going to present it differently so I can now see which feature is, which column actually represents which feature. So later on, while I work with columns, it's easier for me to figure out what am I really working with. Now, this can all completely be done in a very different way. As you all probably know, there are more than one ways to do a thing, and especially in code, many different ways. So I'm not claiming this is the most efficient, but to me this was the most intuitive, and that is why I'm presenting it here. This is definitely becomes much easier when you use data sets, the Wolfram language data sets. That it's much more organized, and then we can quickly apply functions to rows and columns with the data sets and associations. While I'm putting it out there for today, for the purposes of this particular presentation, I'm going to stick with lists of lists and just work through it. So I want to do a quick analysis of these features. What do I have in there? What type of information? What type of, do I have strings? Do I have numbers? Do I have something else? Are there empty rows or empty columns? How many unique values does each column have? And so I've written this bit of code, and then again, don't get lost in the code. Just try to follow along. What am I trying to do? And I hope the result shows here. So here I have the feature in this column here. I'm trying to see what type of feature it is. So I see it's a real number here, or there is a string, and here's a combination of real numbers and strings. How many different unique values does that particular column have? So this column has just one unique value because this is from Manhattan. So I think that that's just the one value for the Manhattan borough. And so probably for any sort of discriminative analysis, that's not going to be useful because it's the same for all the samples. There is a neighborhood, and it is almost entirely strings. This particular feature, it has 39 unique values, so probably there are 39 neighborhoods that have samples in this particular example. There are other things, but things to worry about are these features where there seems to be a mix of real and string. So depending on the value, the real features in there, we have to figure out why some of them are reals and why some of them are strings. And then once we have figured that out, probably we want to go in and do some cleaning there to make sure, all are of the same type. And otherwise we can run into problems in further analysis. Let's see, we have the zip code as a real number. Well, we could actually turn it into a real zip code with the help of Wolfram language, and that's where we will bring in some of the extra knowledge base that is built into the language, and that can become very helpful in augmenting your data. There are other things. The year built is also a real number, so probably we want that as some sort of a data object to help us actually work with that, or maybe just leave it as real. Just because we have something available, we don't always need to use it. Depends on what we want to do with it later on. And then we have the sale price as a real number, but here the sale date, interestingly, we have as a data object. So when we were importing the data, Wolfram language was clearly able to understand, okay, this is a date, and it immediately converted it into a data object. So we've got some understanding of what it looks like, what kind of elements are there in this data, but let's actually look at some of the samples itself. So I'm going to pick out 5 random samples where possible for each feature, and where not possible, we just have how many ever we can get. So borough, there's just one unique value, so we just get that one. But here are some 5 samples of neighborhood and 5 samples of the building class category. This looks a little weird, which makes you, think maybe you want to pick this out and paste it and see what's really going on there. There's the tax classes. We see, the ever-present empty string, which can throw a wrench into all your analysis. So that needs to be taken care of. We don't want empty strings in there. This feature seems to be pretty useless. It's an empty string for all the rows, so we probably want to throw out that feature. And there are other information we can see here. We have apartment numbers, we see the zip codes, residential units, commercial units, total units. Here's another red flag. How can the land square feet be 0? So that's again probably missing data that we want to take care of. Year built, tax class at time of sale, and then building class and sale price and sale date. Okay, so let's move on with this. We have a decent idea of the data. But we saw that the two things we need to look out for, there were zeros and there were missing empty strings, which both probably denote missing data. So let's take a quick look to see how many zeros and how many missing empty strings did we have for each feature. So we see some features are pretty clean, but then here we have 111 empty strings for this particular feature, tax class at present. And then we see the zip code has 2 zeros in there, which is probably again missing data. It should have been a proper zip code. And you can see there are a whole bunch of zeros here for the area of the land, or the land square feet, gross square feet, and then even missing data for year build. So these are the things to look out for. So for data cleaning for this particular data, let's just get rid of the empty strings and the zeros. So what I'm going to do is I'm going to actually trim the string values here, because we want to get rid of preceding and following strings from the strings. And now if we do a string trim, then we can easily get rid of empty strings. So especially for features 4 and 8. So let's go back here. The tax class present, which had 111 empty strings, and 8 building class at present, which also had 111 empty strings. I'm going to go ahead and remove the empty strings, replace them with the missing object in the Wolfram language, which allows us to easily represent missing data. And for the other features, the ones that are here, feature numbers from 11 to 20, some in between there, I'm going to replace 0 or 0 point. So either it's an integer 0 or a real. I'm going to replace it with missing as well. Okay. So now I'm going to drop the column 1 and 7 as we had discussed, because we saw column 1 has the same value actually up here. Column 1 had just one single value, and column 7 didn't have any values at all. So let's go ahead and drop those columns and restructure the data. Okay, and now let's look at the dimensions of the data. We still have 17,727 rows, but we only have 19 columns right now. And let's do the same restructuring for the feature name so that we can use that usefully later on. So now we have 19 features instead of 21 because we dropped 2 features. So this is where we did some data cleaning. Now that we have a reasonably clean data, let's actually do some exploratory analysis. Okay. So this is where we play around with the variables and see what they look like. So we are going to see if there are some samples where there is no sale price. We are working with sale prices of homes. We want to see if there are samples that there are no sale price. Now, sale price, remember, was the last but one column, and hence I'm trying to look for the pattern where I have, a wild card, anything, and then in the last but one column I have missing, and then last column I can have anything again. And I have, these are my samples with missing sale prices. Let's see how many of them I do have. 3,746. Let's take a look at what they look like. Okay. So here, the sale price is missing. And some additional data is missing for these as well. So what's common in all this samples I'm showing you here, the sale price is missing. But let's actually try to see what's going on with this data. I wanted to see so the sale date records when the transaction happened. So apparently for this data, the transaction happened, but the sale price was not recorded. So I did dig into the website a little bit. Apparently, if the ownership changes without a real sale, then these sort of samples get created, where there is a sale, but there is no sale price. And so I wanted to see when these sort of things are happening. Now, since I have the dates, it was very tempting to do a timeline plot on this. Unfortunately, that took forever because there's like 3,000 3,000 sample points here. So getting a timeline plot was not that easy, but it eventually happened. I'm not going to try and do it live, but I'm going to show you the result here. You see somewhere here on the 7th of August, there were a whole bunch of these transactions that did not have a sale price recorded, but then a transaction had really happened. So during the exploratory analysis phase, all these sort of interesting things can crop up. I can do a similar analysis that happens much faster is if I do a count of the sale dates, and then I can just do a dateless plot. So basically, I gather together all the sales that are happening, transactions that are happening on a particular sale date, and then I plot it across the dates. And so that same peak I can see here. And so, if that's what I want to really know about, I can zoom in there and do further analysis. Another quick exploration I can do is I want to see for these particular buildings where the sale price is missing, what are these particular buildings looking like? So I count the number of the different types of buildings that have these transactions recorded, and I take the top 10. I see these are the top 10 that seem to change hands without a sale price being recorded. And again, it's boring to look at numbers, so we can always make pictures out of this sort of information, and so I can visualize it as a pie chart here. And my intention to show you is this: at this exploratory phase, that's our stash of algorithms or functions that we have to offer can make it really easy to walk through this data and see if we can find something interesting. Okay, so now let's actually work with the more interesting part of the data, which is buildings or transactions that actually did have some sale price recorded. So we are just going to delete the missing data from this now. And so now we have sale transactions that have some sale price recorded, about 13,981 transactions. So let's do some explorations with this. So remember we had the zip codes. So let's see. That was in one of the columns there. Let's take a quick look at what were the features like. Okay, zip code was here, column number 9, right? So we are going to get the zip code out, and we are going to actually convert the real numbers that are standing in for the zip code to actual zip codes here. So we have this interpreter of the type zip code, and when you have the notebook, which I'll be uploading shortly, you will be able to actually work with it, and you can hover over a particular function name if you like, and you can open up our documentation about it. And here you see we have the documentation about interpreters. And you can see the number of different interpreter types we have. The usual string, numbers, and so on, but then we also have other things like URL, email address, dates and times. I'll leave it up to you to go ahead and explore this. So anyway, we have the zip codes now. So let's go ahead and quickly see how many transactions happened in the zip codes. And for that, since I have the zip codes, let me show you an example of the zip code. So it's an entity which is a smarter object. So rather than just the number representing the zip code, it's now an entity of type zip code, and it has a whole lot of other information. So I can show you what sort of information it has. So I went from, the flat zip code, which was just a number, to more information about this zip code. And one such information that's available with this entity is the geographical location. I'm going to use that to actually. So this is all a whole bunch of information that I can just get from the zip code. I'm going to use the geographical location to actually plot this out in a map and show you, which is color coded by the number of sales happening in each zip code. So that's what I did with this georegion value plot. So if I am really interested in the zip codes where most number of transactions occur, I can zoom in easily from my map and work on it. Okay, so these were some examples, and then I have a whole bunch of other examples too for exploratory analysis, but I don't want to, test your patience for long. Let me show you just one other quick example. Let's do an analysis of the ages of the buildings. So I'm going to make a histogram of how old the buildings are. So I'm just going, because it was a real, I'm just going to subtract it from the current year and find the age. And so you see I have the number of buildings here that are just 10 years old, 50 years old, 100 years old, or there's some that, this is interesting. I'm not too sure about that. That appears to be 200 years old. But anyways, that's what exploratory analysis is supposed to do. Draw your attention to, things that stand out. Okay. One more thing that I can do is I want to see the total sales on a particular day. So I'm going to group by group the data according to the sale date, and I'm going to add up the number of the amount of sales on that day, and I'm going to create a dateless plot. So on this particular day, there was sales upwards of $2.5 billion here. So it might either be there were a lot of sales, or there might have been this huge sale of a building that was really highly priced. So moving on from exploration, let's actually try and do some modeling. What we'll try to do is predict the home price based on all these additional features that we've been saying. But before jumping into modeling, we'd like to do something that's called data pre-processing. That is basically prepare our data to actually do the modeling. So for data pre-processing, once again, let's take a quick look at the kind of features we have. Okay, these were the features we had. So I'm going to pre-process the data. So basically reformat it, restructure it, and prepare it to be a useful input to the classify or predict function, a machine learning function that I'm going to use later on. So what I'm going to do is I'm picking up only the homes that have sales price more than 5 million, sorry, less than 5 million. And then I'm just reformatting this data. What I'm trying to do is, I want to take the neighborhood, the building class category, the tax class, and so on. And I'm going to leave out some of the features. Now, some of the features, remember, there were both real numbers and strings. So that is why I'm going to try and convert each to string to make sure I have only string features and I don't have a mix of numbers and strings. And then I'm also going to take care of missing information and basically just get it ready to use it for my classifier or predictor. Let's take a quick look at what this now looks like. Okay, not very different. So I have a whole bunch of features. And it points to the sale price. So this is the way I need my data structured so that I can feed it into a machine learning algorithm. So based on these features on the left, I'm going to predict the target value, which is the sale price on the right here. Okay, but there's just one more step before it. You see, I have a mix of features. I have nominal or categorical features, which are names, like the name of the neighborhood, financial, Upper East Side, so on. And I have numbers as well here. So this is a real number, or here, or I think there's the age of the building somewhere here. So I have a mix of words and numbers, right? If I just throw it blindly at my machine learning model, it might not do that well. So one thing that I would like to do is convert these features a little bit into a useful form. So I want to use these, the nominal or categorical features, as an integer vector. So basically an integer code for each nominal or categorical class. So financial probably will get, say, an integer code of 1. Upper East Side can get a code of 2. And so I'm going from nominal or words to numbers because it's always easier to work with numbers. Okay. So now let's bring in some machine learning. Now that our data is ready, I am going to break up this pre-processed data set that I have. I'm going to break it up into a training set and a test set. So I have 9,952 samples in my training set, and let's see how many I have in my test set. Okay, good. And now I'm going to bring in our built-in function predict. And again, you can look it up in our documentation. So what you basically have to do is give it a training set. And I also gave it an option to use the feature extractor based on the feature vector that I created here, right? So some of the features, I want them as integer vectors. Some I want a standardized vector because, you know, these numbers are all over the place. I would rather have them standardized so that I can actually compare one feature to another. And so I'm going to go ahead and run this to let the predict function actually figure out what sort of an algorithm, a machine learning algorithm, would be the best choice in this case to be able to predict the sale price of a home from the information that was given to it. So you can see the progress indicator. Right now it's looking at linear regression, and you can see how the standard deviation is changing, giving us an idea of how it is performing. Now it moved on to random forest and then on to gradient boosted trees. It's trying out these different algorithms under the hood, trying to decide which one is the best. And we can see which one it picks up right now. I think it's going to stick with gradient boosted trees. I did wanted to actually let you pick your algorithm, but at this point, I think we might be running a little short on time, and so we'll skip that. But you know, you should be able to set, if you have your favorite algorithm for this sort of predictions, you should be able to actually use the predict function. Okay, sorry about that. I don't know what happened here. Okay, let's try that again. So it might have run into some issues. Okay, let's just try that again. What I wanted to say is you should be able to actually set the method here. And let's see, we can, I'm just going to pick gradient boosted trees to reduce the training time so that it's not going to try all the different methods to pick. I'm saying just go with gradient boosted trees. And so you can actually set your own method, whether you want decision trees, random forest, just plain linear regression, and so on. And you can work with predict. You can tell predict to train a model just with that algorithm. And we'll see if it can go ahead and complete. It's used about 15% of the training set, moved up to 80%. And we have a predictor function that we can use now and we can use it on some test data. So remember, we had created a test set. So I'm going to use something called predictor measurements, again, a built-in function. I'm going to give it this predictor function that we have trained on the training data, and I'm going to give it some test data, and I'm going to get some measurements of how well this model is performing. There's a whole bunch of things we can get out of it, but for today, I'm just going to show you the comparison plot, which intuitively shows how this has, how the predicted prices are performing against the original prices. So I can sense a lot of eye rolls there. Well, this is not the best model, and I understand. However, I must point out to you, we did, the simplest analysis. We didn't try any sort of feature engineering, or, we didn't really go in there and clean the data a little better. I just showed you some basic cleaning and so on. So I think we can benefit with a little more of feature engineering, feature selection, feature extraction, and maybe even a reduction in the number of features, because I don't think some of them might be overlapping in information. So maybe a little bit of dimensionality reduction. All these different things can help us improve the performance of the model. But for now, this is the performance we have. We do have some that fall on the nice line that we would expect for perfect predictions, but then there are a whole bunch of these samples all over the place. But I also want to draw your attention to the fact that how easy this was to create this visual representation of the model's performance. It's all built in the language itself, in the machine learning toolbox that we have. So once we are done with this, let's see what else can we do. So this gives me an understanding that the features as such, they can do a reasonable job on predicting the price, but it needs more work. So what else can I get? What other things can I get from my data here? I asked the realtor friend of mine, and he said, you know what, we always have to do this comps analysis. For when we are about to sell a home, we compare it with, representative homes in the same area. And the way these listings are usually set up for the realtors is they have to go to each individual page and look at them and then try to figure out, okay, is this a reasonable comparison? But machine learning can make it so much easier, So let's see if we had to share the insight with this realtor friend of mine. What could I do for him? So I would just reformat the data a little differently. So I restructured the data in this way. Actually, let me just show you a couple of random samples from there. Okay, show a little more, come on. Okay, so I grouped the data by neighborhood. So if there was a sale going on in a neighborhood, I put it all together, and I have the information set up so that I have a whole bunch of features, and then I have the address of that place and the price that it was sold for. Sorry, the address of the place is up till here, and then the price it was sold for. Okay, now that I have this information, I am actually going to try to do some deduce. Given a sample, I want to figure out 5 nearest homes, 5 homes that are comparable to this building that I'm looking at, the sample I'm looking at. So let's see. Let's pick up 2 neighborhoods. Okay. Remember, I had 39 different neighborhoods here. So there's Washington Heights Lower and Little Italy. So what I want to try and do here, I'm going to pick up a sample from one of these homes here, one of these neighborhoods here. So let's pick up a home, a building or a transaction from Washington Heights Lower, and I am going to look at 5 similar buildings or homes or whatever from Little Italy, and I'm going to see what was the sale price of those homes. So what I can do for that is, again, I have that problem where I have a combination of numerical data and nominal data, words and phrases, text. So I do want to get all that into numbers, because with numbers it's easier to calculate the distance. So you can quickly calculate mathematically how far a sample point is from another if all that you have is numbers. So for that, what I'm going to do is something called feature extraction, again with our built-in function, feature extraction. And I am going to get all the data from Little Italy here. I'm going to build up a feature extractor function. So what this function will do when I feed it similar information, mix of numbers and text, it's going to convert it all into numbers. So let's see, let's look at it at play here. I'm sorry. Okay, so now you see all I have is bunch of numbers, no more words there, right? So I have all these numbers that represent that sample, and then I have the address and the price of that sale. Okay, so now for comparison, where was the random sample from Washington Heights? So this was our sample from Washington Heights. So what I'm going to use is our nearest function. And I'm going to find the comparisons for this particular example. So Washington Heights and these feature values. It had a sale price of 1.9 million. So let's see what comparable prices we get in the neighborhood Little Italy, 5 closest buildings for this particular building here based on its features. So these are the ones we get. I see this address repeated twice, which probably means it has apartments. And so even this one here. So probably there are apartments there, the same building, but different apartments. But yes, this information I have, that's great. But one thing that my realtor friend also mentioned, that they love to look at it on maps. So I can get it in there. I have this as a string, the address, but I can again use our interpreter and convert it into a street address here. And then I use our geographics function, specifically geographics and geomarker, to actually show this information that I obtain, these comps that I obtain on the map. So the interpreter sometimes hits our servers, and so it might take a little while. And so now I have nicely laid out on the map the comparable sales to the sample that I had picked out. They are at these addresses, and these were the prices they sold for. Okay, so that was a quick run through of the workflow. And what I wanted to point out to you right now is that once you've done this analysis, we did it like a scratch pad, right? We tried different things. We tried to comment as we go on. I made these sections to show what we were working on. And now I can just collapse these and see that this is really the workflow we built up. We imported the data, we cleaned the data, we explored it, we did some pre-processing, we used machine learning, and then we tried to share the insight that we get. Once you've done this analysis, it is very easy to actually pretty it up a little more. I can go into these sections, put in some more text, just off the top of my head. Put in comments, useful information, pretty up your notebook. And then again, what you can do is just go ahead and share it. So I'm going to go ahead and share this with you. If you want to share your analysis right away with the rest of the world, or there are other options, and I'm going to show that to you in a moment as soon as I get the link to share with you. Okay. Okay, again, you can download this notebook and then work with it or play around with it, try other different things. But that's just not the only way to share the information. What I also want to point out, I'm sorry. Sorry, I have too many open windows here. I'm trying to find out the right information. Right. So we have a whole other suite of functions here. We have Cloud Publish that I showed you right now. Then there's also Cloud Share, Cloud Deploy. Cloud Share would be something you would use if you wanted to just share your notebook with coworkers who are working with you on the analysis. And then finally, we also have Cloud Deploy, which is the the top end where you have a product that you have created that with your model running on the background, and you want to create a little microsite with that model running on the background, letting your users interact with your model and analysis. That would be something you would use. So switching gears and wrapping up the presentation today, I want to talk about, this workflow that we created can also be termed as a pipeline. And so I just want to wrap up that, while it's fun exploring and doing things, trying on different things, probably it's helpful to have, a general compass heading to remember that, the idea is, after all, to get from a question to an actionable insight. So you need to have that question in mind and how you're going to get to the actionable insight. So just ending the presentation today, wanted to point out that we have this world of data. We're getting all this information in, and we are trying to use it to the best of our abilities. So having in mind that you want to start out with the question, and the purpose of data science is really to get to an actionable insight. So having these 2 points clearly in mind helps us get more out of our data science project. And so trying to get from this question to the insight, what we need is a data pipeline, which is like the set of code that handles all the computational tasks from beginning to end. And why do you need the pipeline? Because it can give you agility and reproducibility. You can do the same analysis over and over again. So with a lot of things in life, it's better to have a plan or workflow. If you're cooking a special meal, you don't just want to throw whatever you have in the pantry into the pot. You probably want to get your groceries. If you have fresh vegetables, you're cleaning and prepping them. You're picking the right utensils to grill or saute or bake or whatever you want. And then finally, you also want to probably garnish and present the meal as best as you can for the special person you're cooking for. It's kind of the same for data science. You know, while you don't have to do them, you have probably your own workflow, but it helps to have keep tabs on certain things that need to be done. And that is what this pipeline is pointing out to you, is that probably you start out with a question, you get the data, and there's something that you call wrangling. So all the parts where we got this data from the Excel sheet in our example, and we were reformatting it into the right kind of input for the predict function, or the way we wanted to work with it when we were finding the closest comparisons. That is data wrangling, but it can also lead on to data cleaning, where we worked with the missing data, taking care of the zeros and the empty strings and so on. And once you're done with cleaning, we did some exploratory analysis. That's where you are trying to figure out what can you get from this data really. Then you can go on to pre-processing. Now you have an idea what the data looks like, how you need it for your modeling phase, where you do statistical analysis or machine learning. And often you go back again and go have multiple iterations of these various stages of the pipeline until you're happy with your model. And then you're ready to validate it, make sure that it is doing what it's supposed to be doing. And once you're happy with that, you're ready to tell your story, which hopefully will lead to an actionable insight. So with that, we hope we have been able to give you some pointers to how you can use the Wolfram technology to build your data science workflow, and how you can have a multi-paradigm approach while building this. So I'm going to wrap up the presentation and move on to questions, but we are going to end with a poll. We would like to know that if you see your workflow in sort of this pipeline manner, where do you anticipate spending most of your time in this pipeline? Okay, so one thing I definitely want to point out, and let's see if I can share my browser after the poll is done, of course.
And I'm not sure if you've seen it in the chat, but we have had a number of questions about using R, Python, and Excel with the Wolfram language.
Yes.
So that would be.
So we do have something that's called external evaluate that allows us, it's out with 11.3, that allows you to actually pull in your existing Python library or R and incorporate your code from there into Wolfram language. So if you've already done substantial work creating things, you don't have to throw it out. You can always incorporate it in. But we hope you will also look at some of the stuff that we have that should make it much easier to do things in the Wolfram language. So yes, interfacing with other technologies is definitely possible. So we are sharing with you the results. We see that 13% of you are actually thinking that you might be doing a lot of data wrangling, 31% data cleaning. That was expected. Some of you with exploratory analysis, about 26%, 29% expecting to spend time in machine learning and statistical analysis, and just about 1% preparing your reports. But I do want to point out, preparing the reports can be the most important part of your analysis. Like, you do want to convey the story. And I think we make a great case there. We have all the tools available for creating these stunning visualizations that you can actually share easily with the world. I was going to point out our Wolfram, how easy it is to share things on the Wolfram cloud. But as I try to bring up my browser, Sweet, do you want to share something quickly on the EPC? I see there is a question. There has been some questions there, and you had something to share about the enterprise private cloud. Would you mind sharing it live with the audience?
There are some use cases that we can look at with enterprise private cloud. Look at a couple of these right now. So this one is pretty interesting, direct to client analytics. If you go to this website right here, there is a workflow here where you connect to external databases, build a qualitative model. You have coding and some instant APIs that are then modeled automatically and then pushed to a user interface. You can run simulations there. So this particular workflow goes through how this would work using our private cloud. There's also centralized computation and reporting, another use case right here. And I'll go ahead and push this out to all of you on the webinar so that you can look at this on your own time. Enterprise private cloud is something that a lot of our customers do use in data science applications, some that Abrita went over, and in greater detail here. Let me go ahead and push this out to all of you right now. Let's see.
Are you able to see my screen right now? So I'm showing you this cloud notebook that we sent out earlier on in our invite, and with the help of this, I want to point out how you can actually use this to enter our cloud platform. So when you have the link to the notebook or the link to some of the other notebooks that I sent out during the examples with the tweets or the real estate example, you'll have this open in link at the bottom, and you can go in there and open it in one of our cloud products. Wolfram 1 is our recommended choice if you are getting started with the Wolfram system, or we also have the development platform and then programming lab and Mathematica online. So if I choose Wolfram 1, you should be able to open this notebook in your cloud account. I am already signed in. If you're not, then you will be asked to quickly create a Wolfram ID, and we do offer some free credits for you to, it's free to get started. So you can actually play around and see how things happen, and then later on you can start a subscription if you would like. So that would be an entry point to Wolfram 1. And if you have any questions, feel free to email us, and we'll be happy to follow up with more details on how this works and how you can use it. Let's see. I'm going to just quickly take. Okay, there is an unrelated question about Unity Link. I can try and get back to you later. Yes, we do have Unity Link to connect Mathematica to. It's not related to data science, but who knows, you might be able to use that to get some sort of interesting data in and work with it. I don't think anything in the technology is really beyond you being capable of being used for data science. So limitations on throttles or Twitter API, I'll be honest, I haven't really pushed it to the limits. I've only done some exploratory analysis, but if you do run into issues, please feel free to get back to us. For technical issues, you can email support@wolfram.com, or if you want to know more resources to learn about things, feel free to email wolframu. That's wolfram-u@wolfram.com. That's a resource for all educational material. I can also try and bring it up here to point you. And here we have our data science and statistics catalog, and we also have machine learning if you're interested in that. And we actually also have a machine learning series going on, which Jamie will be talking more about and give you some pointers too. So those are good resources to learn about stuff. Let's see. I'm very happy to see this comment from Andres saying that it's great. Wolfram language would be great for his exploratory analysis. We hope you're able to convince others also and really enjoy working with it. If there are other phases of the pipeline you want to use Wolfram language for, please feel free to get back in touch with us. And Jamie will also mention probably how you can access the entire webinar at a later date, but I will sign off right now and let our host complete the webinar for today. Thank you.
Thanks, Abrita. Thanks very much for that presentation. You've got lots of comments coming in. People enjoyed it. So thank you. Let me share my screen. I wanted to, this is a Wolfram U page that I'm showing from our machine learning topic. This does conclude today's presentations, and we hope you did enjoy the talks and learned about concepts and tools you can use to unleash the power of your data. An email will be sent, as Abrita said, to everyone in today's audience with a link to this recording and download links as well for the presentations. We look forward to seeing you online again on May 16th for the second webinar in this data science series. Our topic will be automated data science. You'll receive a reminder email about this session. And I also want to invite you to sign up for the machine learning webinar series that you see on your screen right now at Wolfram U. We'll go ahead and put that link up in the chat. This series continues on May 9th, and you can find that sign up link on our Wolfram U pages or any of our Wolfram site. Our homepage, I believe, has a link at the very bottom under upcoming events. We really do appreciate your feedback, and we use survey results to guide us in making improvements in the Wolfram technology stack and adding features important to the user community. So a survey will pop up in your screen as you exit today, and we value your input and comments and feedback. So thank you very much for joining us today. We'll see you next time. Have a great day.